The morning of December 7th, 1941, broke across Pearl Harbor with deceptive tranquility. Golden sunlight painted the anchored battleships in shades of amber and slate, casting long shadows across water that would soon turn black with burning fuel oil. The Pacific Fleet lay at rest on what should have been a peaceful Sunday. But at 7:55 in the morning, that peace shattered. Japanese aircraft screamed out of the western sky, their engines tearing through the quiet with a roar that turned blood to ice. Within moments, the carefully ordered world of the United States Navy dissolved into chaos, smoke, and the thunderous percussion of exploding ordnance. Marine Gunnery Sergeant Tom Bruster was walking toward the mess hall when the first bombs fell on Ford Island. 2 decades of service had etched themselves into his hands and his bearing. The kind of instinctive tactical awareness that separated career Marines from younger soldiers came naturally to him. As explosions bloomed across the harbor and machine gun fire raked the wooden barracks, he didn't sprint for shelter like the men around him. Instead, he sprinted toward the armory. The Springfield rifle settled into his hands with the familiarity of 10,000 previous touches. He chambered a round and adjusted the leather sling with practiced efficiency. The Lyman scope mounted above the bolt was standard issue, a 5-power optic with a 3/4-inch objective lens that the Marine Corps had been using since the previous war. Bruster had qualified expert marksman with this exact setup on the known distance ranges at Quantico, placing shots consistently within the 10 ring at 600 yards under perfect conditions. But Pearl Harbor that morning offered nothing remotely resembling perfect conditions. Through the drifting smoke and the orange glow of burning fuel, Bruster spotted his target. A Japanese pilot in a Nakajima torpedo bomber was making a low strafing run across the harbor, his machine guns chattering relentlessly at sailors struggling in the oil-slicked water. Wounded and dying floated on the surface like broken dolls, their white uniforms starkly visible against the black petroleum coating everything it touched. The pilot banked his aircraft in a lazy turn, lining up for another pass at the helpless men below. Bruster dropped to a prone position behind a concrete barrier, his elbows finding solid purchase on the rough surface. The distance registered automatically in his mind. 800 yards, maybe 850. Under normal circumstances, with known distance targets and match-grade ammunition, such a shot would be challenging but achievable for a marksman of his caliber. These circumstances were anything but normal. The Lyman scope's 5-power magnification reduced the aircraft to little more than a dark silhouette against the smoke-filled sky. At 800 yards, the pilot himself was invisible, just a theoretical presence inside a machine that moved with deadly purpose through Bruster's limited field of view. The scope's reticle, designed for stationary targets on well-maintained ranges, seemed woefully inadequate for tracking a moving aircraft whose speed and direction changed with each passing second. Bruster's breathing slowed as his training took over. Lead the target, account for the distance, compensate for the crosswind carrying the acrid smell of burning ships across the harbor. His finger found the trigger's familiar resistance, that precise point where another ounce of pressure would send the bullet down range at 2,800 feet per second. The rifle bucked against his shoulder with a sharp crack, immediately swallowed by the larger symphony of destruction. Through the scope, Bruster watched his bullet pass harmlessly behind the aircraft, a clean miss that disappeared into the chaos without effect. The pilot continued his deadly work, his machine gun stitching lines of death across the water. Bruster chambered another round, his movements automatic despite the bitter taste of failure. The aircraft was banking away now, climbing toward altitude where American small arms fire could not follow. In those 30 seconds of controlled breathing and careful aim, the Marine had learned a lesson that would haunt the Corps throughout the early months of the Pacific War. Their equipment simply was not equal to the distances at which modern combat was being fought. 3 months later, the war had transformed from a surprise attack into a grinding campaign of island-hopping warfare where individual marksmanship could mean the difference between mission success and catastrophic failure. Casualty reports arrived daily at Marine Corps headquarters in Washington from places with names like Wake Island, Bataan, and Guadalcanal. Young Marines trained in the peacetime shooting techniques of known distance ranges were discovering that Japanese snipers consistently outranged them, picking off American forces from positions that existing equipment simply could not engage effectively. Captain George O. Van Orton of the Marine Corps Equipment Board understood these limitations with perfect clarity born from personal experience. A competitive marksman who had won multiple championships at Camp Perry, Van Orton combined the analytical precision of an engineer with the practical wisdom of a combat officer who had personally tested every piece of equipment he recommended. His office walls displayed certificates and trophies spanning 2 decades of shooting excellence. But the reports crossing his desk told a starkly different story about American marksmanship capability under actual combat conditions. The journey to Pittsburgh on that cold February morning represented far more than a routine equipment evaluation. Van Orton carried with him the weight of mounting casualties and the growing certainty that American forces were fighting with obsolete tools against an enemy who understood the tactical value of superior optics. The train ride through the Pennsylvania countryside gave him time to review technical specifications he had already memorized. The Lyman 5A scope represented the state of American military optics as it existed in 1942. A reliable, rugged design that offered adequate performance under the controlled conditions for which it had been developed. 5-power magnification provided sufficient target resolution for known distance shooting up to 600 yards. The 3/4-inch objective lens gathered enough light for clear visibility during optimal conditions. The internal adjustment mechanisms were simple and robust, designed to withstand the rough handling that military equipment inevitably received. But adequate performance under controlled conditions was proving insufficient for the realities of Pacific theater combat, where engagement distances regularly exceeded 800 yards and environmental conditions challenged every assumption about equipment reliability. The small optical shop on Liberty Avenue looked unremarkable from the street. Its modest storefront wedged between a hardware store and a delicatessen, in a neighborhood where immigrant craftsmen had been perfecting their trades for generations. But inside, John O'Neill Sr. had been quietly revolutionizing precision optics with the same methodical attention to detail that had made German manufacturing synonymous with quality throughout the world. The rejection letter arrived on a Tuesday morning in late spring of 1942. Delivered by courier to the Marine Corps Equipment Board offices with bureaucratic efficiency. Captain Van Orton read Colonel William Sterling's carefully worded paragraphs twice before setting the document aside. Any new sniper rifle system will be based on the proven M1903 Springfield platform, the letter stated with administrative certainty. The Winchester Model 70 proposal lacks sufficient field testing under combat conditions to warrant adoption during ongoing operations. We do not change horses midstream. The decision reflected institutional thinking that prioritized proven systems over innovative solutions, a conservative approach that valued reliability above performance improvements. Yet at Camp Lejeune in North Carolina, a 3-month evaluation program had generated data that told a remarkably different story. Marine armorers had conducted exhaustive testing of both the Winchester Model 70 and modified M1903 Springfield rifles, both platforms mounting John O'Neill's 8-power civilian scope. The numbers were remarkable by any standard of military accuracy. Consistent 3.5-inch groups at 600 yards with match ammunition. Sub-minute of angle precision that exceeded existing military specifications by significant margins. Master Sergeant Bill Harrison had supervised much of the field testing with the skeptical eye of a range instructor who had watched fancy equipment fail under stress. 20 years of Marine service had taught him to distrust complicated mechanisms, particularly when they would be maintained by 19-year-old Marines operating under combat conditions where proper cleaning competed with immediate survival needs. The scope's external adjustment knobs and sliding mount system represented exactly the kind of complexity that made experienced non-commissioned officers nervous. "That contraption's got more moving parts than a pocket watch," Harrison muttered as he examined the scope's micrometer mechanisms during a morning inspection. Corporal James Mitchell from rural Kentucky nodded in agreement while carefully cleaning the scope's objective lens with a soft cloth. Mitchell's hunting background had made him a natural candidate for sniper training, but his practical experience with simple, reliable equipment made him equally wary of the scope's delicate appearance. The weather during the testing period had been typical for coastal North Carolina, humid, unpredictable, and hard on precision equipment. When rain began falling during a particularly important accuracy trial, both Harrison and Mitchell watched nervously as moisture accumulated on the scope's external surfaces. Within hours, the delicate adjustment mechanisms were binding up, requiring careful cleaning and lubrication before normal function could be restored. Back in Pittsburgh, John O'Neill Sr. received detailed reports of each equipment failure with the methodical attention of a craftsman who understood that perfection existed only in theory, not in the field conditions where his scopes would ultimately serve. Working 16-hour days in his small shop, he handcrafted modifications to address each documented problem, grinding lenses by hand and machining components with tolerances measured in thousandths of an inch. Emma O'Neill brought her husband coffee at midnight, finding him hunched over precision lathes that filled the workshop with the sound of cutting steel. The thick German accent resonated through the workshop as he laid out his latest improvements with unmistakable passion. These instruments, they must perform flawlessly. The young men, like our horns, they depend completely on this equipment to survive. Thoughts of their son, now stationed with the Marines somewhere across the vast Pacific, gave every moment of work an intensity that never seemed to fade. The durability issue had become the central problem, blocking military acceptance. When field tests ran for extended periods, the scope's mounting system began to fail under the brutal stress of repeated gunfire and recoil. The long tube shifted slightly with every shot. This tiny movement meant constant readjustment, work that undermined the entire accuracy advantage the optical system was supposed to provide. Salt air and moisture wreaked havoc on the external adjustment mechanisms, freezing the precision knobs solid and making field corrections nearly impossible. Military inspectors documented each failure with meticulous detail, creating an unmistakable record of performance problems. One particularly harsh assessment delivered the verdict plainly. The equipment proved too fragile for sustained combat. Field maintenance demands exceeded realistic capabilities, not recommended for adoption. These words carried the weight of experienced soldiers and institutional responsibility for Marine lives. Yet even as durability concerns mounted, casualty rates across the Pacific continued climbing with each new amphibious landing. Guadalcanal had proven that Japanese defenders prepared positions with care, positioning superior optical equipment to inflict devastating casualties on attacking Marines. Tarawa would exact an even steeper price, with American forces crossing open beaches in withering fire from concealed positions that current American equipment simply couldn't engage effectively. In late summer, Corporal Mitchell received his assignment to the Pacific, joining the 4th Marine Division as it geared up for operations that would pit American amphibious tactics against increasingly formidable Japanese defenses. His final letter back to Kentucky before deployment captured the complex emotions of young Marines facing their first real combat. "Mom, this new scope is something special. I can see individual leaves on trees 600 yards out. It feels almost like cheating." By late 1942, the first production models arrived at Marine units packed carefully in wooden crates, each one accompanied by detailed maintenance guides and specialized cleaning kits. These M1903A1 National Match Rifles had originally been built for competitive marksmanship, precision instruments never envisioned for battlefield use. The bolts bore a careful polish and bluing that eliminated any shine that might betray a sniper's position to enemy eyes. Every technical detail represented a compromise between civilian precision engineering and military durability. The scope itself offered 8-power magnification through a 1.5-inch objective lens, gathering nearly twice the light that older military optics could manage. Effective range stretched beyond 800 yards under favorable conditions, a 60% improvement over what previous equipment allowed. The mounting system clamped the scope firmly to specially configured M1903A1 rifles through machined blocks that held everything solid while permitting removal in the field. By mid-1943, initial combat reports painted an encouraging picture. Marine snipers operating on Tarawa reported successful shots at distances exceeding 800 yards, ranges that the Japanese had previously considered completely safe from American small arms fire. Enemy forces, accustomed to operating beyond what they thought was American effective range, suddenly found themselves vulnerable at distances they'd considered tactically secure. Yet these promising early reports were soon overshadowed by devastating assessments arriving from units fighting in the humid jungle environments dominating much of the Pacific theater. The 1st Marine Division's after-action report from Cape Gloucester was unsparing in its judgment. Unable to effectively employ the M1903A1 rifles due to climate and terrain. Similar conclusions came from other units operating in high-humidity regions, where precision mechanisms began failing with alarming frequency. These negative reports hit Marine Corps headquarters like concussion grenades, each one eroding confidence in equipment that had performed so well under laboratory conditions. Colonel Sterling's voice held unmistakable vindication as he studied the field assessments. "I told you that contraption wouldn't survive real combat conditions." The military's traditional reliance on proven systems over unproven innovations seemed validated by battlefield evidence that nobody could dispute. Yet the decision to continue the program came not from confidence in the equipment itself, but from desperation created by mounting American casualties across the Pacific. By late 1943, Marine leadership grappled with brutal mathematics. Every major assault generated thousands of American casualties, many inflicted by Japanese snipers firing from ranges where existing American weapons couldn't effectively respond. Maintaining offensive pressure against Japanese island fortifications demanded solutions, even imperfect ones, carrying significant risks. Captain Van Orton received approval to proceed with limited production, though the restrictions attached to this approval reflected headquarters' skepticism about the system's practical reliability. Every scope would come with maintenance protocols specifically designed for high humidity conditions. Special carrying cases manufactured from moisture-resistant materials would shield the delicate mechanisms during movement. Most importantly, scopes would mount exclusively on M1903A1 National Match Rifles, weapons whose inherent precision could best exploit whatever advantages the optical system offered. John Unertel Sr. recognized this as his final chance to demonstrate that civilian optical precision could genuinely serve military purposes. In his Pittsburgh workshop, working through endless days and nights, he implemented modifications targeting every documented failure from field trials. The scope tubes received reinforced internal construction to block moisture penetration. The external adjustment mechanisms underwent complete redesign with larger, tougher components capable of functioning despite sand or salt spray contamination. Every lens underwent individual testing under simulated combat scenarios mimicking the temperature swings and humidity levels Marines would encounter in Pacific operations. The production quota of 2,800 scopes represented an enormous undertaking for a small optical company that had previously concentrated on civilian target equipment. Emma Unertel expanded the business with composed competence, recruiting skilled craftsmen and establishing production schedules that accommodated her husband's exacting standards while meeting military deadlines. Each scope required dozens of precisely machined components and countless hours of skilled hand assembly. By technicians who understood their work, would ultimately be tested under conditions where failures meant American lives. The M1903A1 rifles, designated for the sniper program, underwent extensive modification to properly accept the scope mounting system. Marine armorers at the Philadelphia Navy Yard created detailed installation procedures, machining each rifle's receiver to exact specifications, ensuring the scope would maintain accuracy through repeated firing. The polished bolts characteristic of national match rifles received careful bluing to eliminate reflective surfaces, potentially revealing a sniper's position. Trigger assemblies got adjusted to deliver crisp, consistent breaks complementing the optical system's precision capabilities. In early 1944, Corporal James Mitchell received his assigned rifle while training with the 4th Marine Division at Camp Pendleton. Serial number 1464 displayed the Springfield armory markings and meticulous finishing, distinguishing national match weapons from standard infantry rifles. the scope mounted above the action represented months of dedicated development work. Its 8-power magnification and crystalline optics delivered target detail Mitchell had never previously encountered. The training program emphasized scope maintenance procedures as much as marksmanship fundamentals. Marines learned to disassemble and service the scope's external components using specialized tools engineered for field conditions. Protecting mechanisms from moisture became a critical skill taught through thorough instruction in protective cover usage and desiccant materials, preventing the humidity failures that had plagued earlier tests. Every sniper demonstrated maintenance proficiency before receiving combat certification. Camp Pendleton's field trials validated the system's capabilities while revealing the expertise necessary for proper operation. California's dry conditions allowed the modified scopes to perform without fault, delivering accuracy measured in fractions of an inch at ranges surpassing 800 yards. Marines previously constrained by existing equipment limitations suddenly found themselves capable of precise engagements at previously impossible distances. Mitchell's familiarity with the system grew steadily, his Kentucky hunting experience providing natural intuition for precision shooting that transferred seamlessly to military applications. Training scores regularly exceeded standards, with 600-yard groups measuring under 4 inches using standard M2 ammunition. Equally important, his trust in the equipment deepened through each practice session, building the psychological confidence essential for combat effectiveness. The first operational deployment of the M1903A1 system occurred with the 4th Marine Division's assault on the Marshall Islands during early 1944. Kwajalein and Majuro offered ideal conditions for testing the precision scopes. Relatively dry climate, excellent visibility, and defensive arrangements favoring long-range engagement over the close jungle combat of earlier operations. Early reports proved encouraging, with Marine snipers confirming kills at ranges surpassing 900 yards. Mitchell's initial combat use of the scope occurred during the assault on Japanese positions along Kwajalein's northern beaches. From concealment behind coral formations, he targeted enemy machine gun crews pouring fire at advancing Marine infantry. The scope's 8-power magnification permitted precise target identification at distances where enemies appeared as recognizable individuals rather than indistinct shapes. His first confirmed kill came at approximately 820 yards, a shot impossible with standard equipment. The tactical impact extended beyond immediate results. Marines previously outranged by Japanese snipers suddenly possessed capability to control the precision shooting environment, characterizing much of Pacific combat. Enemy positions considered safe by Japanese standards abruptly became vulnerable to American fire at unprecedented ranges. Yet the Marshall Islands' relatively favorable conditions provided only a partial evaluation of the system's durability. The coming assault on Saipan would deliver a far more demanding test, bringing tropical humidity and the coral dust of cave warfare that would challenge every assumption about equipment reliability. Mitchell and his fellow snipers prepared for operations that would test not just marksmanship ability, but their capacity to maintain precision instruments under conditions that had previously destroyed delicate mechanisms. The technical specifications governing the system represented compromises between civilian precision and military durability, ultimately determining the program's future. 8-power magnification offered substantial target identification advantages, yet longer scope tubes demanded more robust mounting hardware, adding weight and complexity. The 1.5-inch objective lens gathered substantially more light than older military optics, enabling effective use during low visibility conditions. However, the larger glass surfaces presented increased vulnerability to environmental contamination. Quality control became progressively critical as production accelerated, meeting combat schedules. Each scope underwent thorough testing, including accuracy verification, mechanical function checks, and environmental stress simulations replicating field conditions. John Unertel Sr. personally examined every 10th scope, his craftsman's eye detecting minute flaws, escaping routine procedures, yet potentially catastrophic under combat conditions. The human cost of equipment failure remained constantly visible throughout the development and implementation process. Negative field reports signified not merely technical inadequacy, but American casualties potentially preventable with more dependable equipment. The urgency to succeed pressed heavily on contractors and military personnel alike, creating intensity transcending normal development timelines and demanding immediate solutions, preserving American lives. The after-action reports from Saipan arrived at Marine Corps headquarters in Washington like successive hammer blows, each document undermining confidence in equipment that had demonstrated such potential under controlled conditions. The 1st Marine Division's assessment proved particularly damaging. The M1903A1 rifles proved ineffective due to environmental conditions and maintenance requirements exceeding field capabilities. Additional reports confirmed this pattern, collectively demonstrating how precision equipment repeatedly failed encountering Pacific combat realities. Colonel William Sterling's voice carried unmistakable vindication as he reviewed the accumulated evidence of system failure during a contentious equipment board session late summer 1944. "Gentlemen, I cautioned against civilian equipment adoption for military purposes. These reports validate that complicated mechanisms have no place in combat operations." His philosophy reflected the way military institutions thought. They favored what had proven simple and reliable over anything new and complicated. It was a conservative approach that seemed to make sense when you looked at what actually happened in combat. The reports coming back from the field told a consistent story. Every concern the skeptical officers had raised turned out to be valid. The problems followed a pattern. Moisture from the humid air would creep inside the optical elements and fog them over completely, making the scopes worthless when Marines needed them most. The coral dust from fighting inside caves abraded the adjustment mechanisms until they froze solid and wouldn't move. But the worst damage came from the mounting systems. Under the punishment of sustained recoil, they would loosen inch by inch, requiring constant readjustment. Every time you tried to re-zero, you lost the very accuracy advantage the scope was supposed to provide. Corporal James Mitchell lived through the human consequences of this failure. During the vicious fighting in the Central Highlands, his inertial scope gave up right when he needed it most. A Japanese sniper nested in a cave system had been picking off Marine squad leaders one by one, creating chaos that slowed the entire advance through terrain where the Japanese held every advantage. Mitchell had found the position through patience and observation, tracking the flash of muzzle fire across nearly 400 yards of valley filled with smoke and dust from constant artillery. His M1903A1 rifle could handle that distance easily with iron sights, but killing a target hiding in a narrow cave opening demanded magnification for accuracy. He settled behind a cluster of volcanic rocks, took aim through the scope, and found nothing but fog. The humid tropical air had condensed on the glass faster than it could evaporate in the crushing heat. He tried everything the manual said to do. Nothing worked. The moisture kept building up. The external adjustment knobs, caked with fine coral dust that had invaded every piece of equipment after weeks of cave fighting, refused to budge. The lubricants from the technical manual didn't help. Mitchell had no choice but to use iron sights at a distance where precision meant everything. He fired 3 carefully aimed shots at the cave opening where he'd seen the muzzle flash. The sniper fired back immediately. The bullet hit his protective rocks and sprayed fragments everywhere. The second round found flesh, tearing through his left shoulder with a crack that told him it was traveling fast and hard. His message to his company commander carried all the anger of a Marine betrayed. "This thing's more fragile than my grandmother's china. Request permission to use standard rifle for remainder of operation." His words meant more than just one man's frustration. Every Marine in the Pacific felt the same way. They'd been promised revolutionary equipment. What they got instead were delicate mechanisms that fell apart under the stress of real combat. Back in Pittsburgh, John Unerthal Sr. studied the field reports with the intensity of a craftsman who understood something terrible. Every documented failure meant American casualties that might have been prevented with better design. He didn't give up. He treated each failure like data. 18-hour days in his workshop led to new sealing techniques meant to stop moisture from infiltrating under extreme humidity. The environmental challenges precision optics faced in the Pacific exceeded anything civilian target shooters ever encountered. Humidity regularly topped 90%. Metal surfaces corroded rapidly, optical elements fogged despite protective coatings. Coral dust possessed abrasive properties that wore surfaces away faster than field maintenance could keep up. Salt spray from amphibious operations attacked steel and brass with relentless persistence. Marine armorers across the Pacific began developing their own modifications. At the Philadelphia Navy Yard, skilled technicians and combat veterans worked together on practical solutions that went beyond anything the official specifications addressed. The gap between how equipment was designed and how it actually performed in combat created opportunities for innovation that the standard procurement system couldn't handle. The real breakthrough came from an unexpected place. Marine Sergeant Robert Chen, operating with the 3rd Marine Division on Okinawa, developed field techniques for protecting his precision scope during movement and storage that dramatically improved reliability under combat conditions. Using salvaged Japanese silk and pure marine ingenuity, he created covers that kept moisture out but could be deployed and removed quickly as tactical situations changed. Chen's improvised protection system kept his inertial scope functional throughout the brutal fighting for Okinawa's southern defensive positions. His kill record reflected what the system could do when properly maintained. 23 confirmed enemy casualties at ranges averaging over 700 yards. More importantly, his success proved something crucial. The equipment could work reliably when operators understood its environmental limitations and adapted accordingly, rather than expecting it to perform like simpler, tougher alternatives. When tactical commanders witnessed the system's effectiveness under favorable conditions, they grasped its potential. Enemy machine gun crews that had dominated their sectors through superior fields of fire discovered they were vulnerable to precision shooting from distances they thought were safe. Japanese snipers who had terrorized American forces found their concealed positions could be identified and engaged with devastating accuracy when atmospheric conditions allowed the scope to perform. But these isolated successes played against a background of systematic failure that destroyed confidence in the overall program. For every Chen achieving remarkable results through exceptional maintenance, dozens of other Marines struggled with equipment that failed at the worst possible moments. The statistical reality of combat demanded reliability percentages. The inertial system, despite its theoretical advantages, couldn't consistently deliver under field conditions. Orders began circulating through Pacific Marine units, directing the phase out of the inertial sniper rifles. The decision reflected institutional priorities that preferred consistent mediocrity over exceptional performance, accompanied by unacceptable reliability risks. Marines who had invested months learning the system's complexity found themselves retraining with simpler equipment that worked more reliably, but offered fewer capabilities. The human cost extended beyond tactics into psychology. Marines who had experienced what the system could do understood what they were losing. Mitchell, recovering from his shoulder wound at a field hospital on Saipan, spoke for many snipers when he expressed his bitter disappointment. Give me equipment that works 70% of the time over equipment that's perfect 10% of the time. Dead Marines don't benefit from theoretical advantages. The forgotten war began with forgotten equipment. When North Korean forces crossed the 38th parallel in June 1950, the Marine Corps faced a desperate shortage of precision shooting capability. Years of post-war budget cuts had reduced sniper programs to skeleton crews. In warehouses across continental United States, hundreds of M1903A1 rifles fitted with inertial scopes sat coated in Cosmoline storage. Their wartime failures seemingly confirming institutional wisdom about the incompatibility of delicate civilian equipment with military requirements. The resurrection came not from deliberate policy decisions, but from practical necessity born of limited resources and urgent operational demands. Marine units deploying to Korea lacked sufficient modern sniper rifles to meet tactical requirements. Quartermasters issued whatever precision equipment remained available in depot stocks. The same scopes that had failed in humid Pacific jungles found themselves shipped to a peninsula where environmental conditions would prove dramatically different from previous combat experience. Korea's dry mountainous terrain played to the inertial system's strengths rather than exposing its environmental vulnerabilities. Clear atmospheric conditions prevalent across much of the peninsula enabled maximum utilization of the scope's 8-power magnification and superior light gathering. Engagement ranges regularly exceeding 800 yards favored precision optics over the simpler, shorter-range alternatives that had replaced the inertial system during the final months of World War II. Marine Corporal Robert Williams received his assigned M1903A1 inertial rifle at the Pusan perimeter in August 1950, viewing the equipment with skepticism inherited from older Marines who remembered its failures during previous combat. The scope bore the manufacturing marks of John Unerthal's Pittsburgh workshop. Its brass fittings showed green patina from age, but the optical elements remained crystal clear despite years of storage. Williams's Kentucky hunting background gave him familiarity with precision shooting, but the 8-power magnification exceeded anything he'd previously used. Training at Pusan enabled him to discover capabilities that had remained theoretical during the system's troubled Pacific deployment. Under Korea's dry conditions, the external adjustment mechanisms functioned with mechanical precision that allowed repeatable scope settings for multiple distances. The mounting system maintained zero stability through hundreds of rounds, eliminating the constant re-zeroing that had plagued the system during humid tropical operations. Most importantly, optical clarity remained consistent throughout extended shooting sessions without the fogging problems that had rendered the scope useless during critical Pacific engagements. Williams's first confirmed kill with the inertial system came during defensive operations around the Pusan perimeter in early September 1950. A North Korean sniper positioned on Hill 207 had been systematically targeting Marine machine gun crews, disrupting defensive positions critical for maintaining perimeter integrity. The enemy position, identified through patient observation, lay at a measured distance of 940 yards. Precision shot placement through a narrow opening between rock formations was required. The engagement exemplified the system's capabilities under optimal conditions. Williams's careful range estimation, combined with precise windage and elevation adjustments using the scope's external micrometer knobs, enabled first-round hits at distances that would have required multiple ranging shots with simpler optical systems. The North Korean sniper, accustomed to operating outside effective American small arms range, found himself eliminated by precision fire delivered from a distance he considered tactically secure. Word of successful long-range engagements spread rapidly through Marine units operating along the Korean front, creating renewed interest in equipment many had written off as unsuitable for combat. Williams's confirmed kill record climbed steadily throughout autumn fighting, reaching 12 enemy casualties by November 1950, all at ranges exceeding 700 yards. More significantly, his success rate approached 90% first-round hits, when atmospheric conditions permitted optimal scope performance. The psychological impact of renewed long-range precision capability extended beyond immediate tactical advantages to encompass strategic implications for Marine sniper doctrine. Enemy forces that had grown comfortable operating at distances they considered safe discovered themselves vulnerable to precision engagement at ranges that redefined the tactical environment. Chinese forces entering the conflict discovered that their numerical advantages could be significantly degraded by individual American snipers equipped with superior optical systems. Technical vindication of the inertial system's design principles emerged through systematic documentation of performance under Korean conditions. The same external adjustment mechanisms that had failed in Pacific humidity functioned flawlessly in Korea's dry climate, providing precise, repeatable settings that enabled consistent accuracy at extended ranges. Optical clarity that had been compromised by tropical moisture remained pristine throughout temperature extremes, ranging from summer heat to winter conditions, approaching -30 degrees Fahrenheit. The mounting system's stability under Korean conditions validated design decisions that had been criticized during Pacific operations. The precisely machined mounting blocks, when properly installed and maintained, provided rock-solid scope attachment that maintained zero stability through thousands of rounds. Longer scope tubes that had been considered unwieldy in jungle warfare proved advantageous in mountain terrain, where concealment distances enabled effective use of extended optical systems. Williams's record-setting kill at 1,200 yards came during bitter fighting around Seoul in early 1951. A Chinese sniper positioned in a bombed-out factory building had been targeting Marine forward observers, preventing effective artillery coordination critical for reducing enemy strongpoints. The extreme range required careful calculation of bullet drop and wind drift, factors the inertial scope's precise adjustment mechanisms could accommodate when atmospheric conditions remained stable. The shot delivered from a concealed position among residential ruins struck the enemy sniper in the upper torso at a distance that established new standards for Marine precision shooting capability. Post-engagement analysis confirmed the range through triangulation measurements, providing documentation that would influence sniper training doctrine for decades. The engagement demonstrated that properly maintained inertial systems could deliver precision fire at distances approaching the theoretical limits of the .30-06 cartridge's ballistic performance. Sergeant James Mitchell, now serving as an instructor at the Marine Sniper School at Quantico, received reports of Korean successes with mixed emotions reflecting his complicated relationship with the inertial system. His World War II experience had taught him the bitter lesson of equipment failure at critical moments. But Korean results suggested that environmental factors rather than fundamental design flaws had caused Pacific theater problems. John Unerthal Jr., assuming control of his father's business after the elder craftsman's death in 1951, visited Marine Corps installations, gathering feedback from snipers who had used the system under combat conditions. The conversations revealed important lessons about the relationship between equipment design and operational environment that would inform future development. Mitchell's assessment was characteristically direct. "Your father's scope saved my life more times than it failed me. We just had to learn how to use it properly." The Korean War provided the extended field trial that World War II's rushed deployment schedule hadn't permitted. Under appropriate environmental conditions, with proper maintenance procedures and operator training, the inertial system delivered precision shooting capability that exceeded existing alternatives by significant margins. Vindication came not through bureaucratic rehabilitation, but through documented battlefield performance that established new standards for American sniper effectiveness. The lessons learned in Korea would prove prophetic for the system's ultimate vindication in Vietnam, where environmental conditions similar to the Pacific theater would again challenge equipment reliability. But by then, both the equipment and the Marines who used it had evolved to accommodate the system's characteristics, rather than expecting it to perform like simpler alternatives. The impossible idea had finally found the right combination of conditions and understanding necessary for its full potential to be realized.